Hello children, Force and Laws of Motion, Class 9, Subject Science, Chapter 9, and this is the part 4. So in the previous class we have studied about the Newton's first law of motion and about inertia, right? So let's look at few examples for Newton's first law. So a fielder moves his hand backward while catching the ball coming with a great speed. An athlete before jumping runs some distance, and seat belts in the vehicles prevent the passengers from getting thrown in direction of motion. So those are the few examples for Newton's first law. So in today's class, let's talk about Newton's second law of motion. So what does the second law tells us? Can you all look at the figure here, diagrams? Yes or no? So pushing an elephant requires a lot of force. Yes or no? So when you try to push an elephant, what happens? You require more force. So whereas hitting a ball is very easy. Yes or no? So if you apply, for example, if you apply a 5 Newton force in order to push an elephant, then to hit a ball, it is much lesser than that. So the same amount of unbalanced force does not produce the same amount of acceleration in different bodies. Yes or no? Here, in case of elephant and a ball, so if you apply the same amount of force, it will not produce the same amount of acceleration. So the acceleration produced is inversely proportional to the mass of the body, which means what? If the mass is more, then what happens? The acceleration will be less, provided the force remains constant in both the cases. Okay? If the mass is less, then the acceleration would be more. Clear? So how can you state that mathematically? So let's say m is the mass of the body, F is the force acting on the body, and A is the acceleration. So acceleration is in the direction of force and is directly proportional to the force. So acceleration and force are directly proportional, and acceleration and mass are inversely proportional. Therefore, when you combine all the equations, two equations, you get acceleration is proportional to F divided by m, which can be expressed as F is equal to m into A. F, whereas where F is force, m is mass, and A is acceleration. So please remember this formula, children. F is equal to m into A. So SI unit of force. So the SI unit of force is Newton. Okay, which means 1 Newton force produces 1 meter per second square acceleration on a body of mass 1 kg. Okay, because mass and acceleration, force is dependent on mass and acceleration. So let's take an example here. Ramu's elephant weighs 1000 kg. The elephant is sick and is not able to move. So Ramu is trying to push his elephant and he makes the elephant go at 0.05 meter per second square. Using Newton's second law, we can compute how much force Ramu is applying to the elephant, which means F is equal to m into A. We know that m, mass of an elephant, is 1000 kg. So let's write in place of mass 1000 into what is the acceleration that he is able to make. He is able to make 0.05. So the force that Ramu applies is 50 newtons. Clear? So 50 newtons of force is applied in order to make a 1000 kg elephant to move 0.05 meter per second square is the thing. Okay. So next we have something called as momentum in second law. So as we have studied about inertia in the first law, momentum in the second law. So what do you mean by momentum? Momentum is nothing but it is the product of mass and velocity. Product means what? You know it's multiplication. Yes, sum in the sense addition, difference in the sense subtraction, and product in the sense multiplication. So momentum is given by mass into velocity. So the SI unit of momentum is kg meter per second. Why? Mass is kg, velocity is meter per second. Therefore, it is kg meter per second. Okay. So whenever the mass is less, which means for the lighter things, what happens? The momentum is also less. Why? Both are directly related. If the mass is more, that is for the heavier objects, the momentum is also more. Okay, and about the velocity, so the applied force can increase or decrease the momentum of the body depending on whether the force and momentum are in the same or in the opposite directions. So things that are not moving have no momentum. Okay, there what happens? The velocity remains 0. So mass, any mass into 0 is 0. So the momentum is 0 for the things that are not moving. So momentum and Newton's second law. So consider a cycle and truck moving with the same velocity. So which one requires more force to stop in the same amount of time? So what happens? So less force to stop cycle and more force to stop truck. Yes or no? So it is the cycle which has lesser momentum than the truck. Why? Because the mass of the cycle is less and the mass of the truck is more. Therefore, whichever the mass is less will have less momentum because P is equal to m into V. So the change of momentum in a given time is directly proportional to the force and takes place in the direction of the applied force. So this is the example. So a force of 1250 Newton acts on a body of mass 50 kg. Find the acceleration. So force is given, mass is given. So how can you calculate acceleration? According to Newton's second law, F is equal to m into a. So for a it is F divided by m. So when you substitute, you will get acceleration. The same you have examples here. So mass is given, acceleration is given. So you can calculate the force. Yes or no? F is equal to m into a. And please write the unit. Understood? Writing SI unit is very important in any given problem. So force is given as Newton. So third example, you have force, you have acceleration. So you have to calculate the mass. So mass is given by F divided by A. So the mass of the body is 90 kg. Okay, mass, you know that it is a weight, 90 kg. And example number 4. You know mass, it is given in gram. Always for a given problem, you have to make sure that the values are in its SI units, standard units. So velocity is given, so you have to calculate the momentum. So momentum is equal to P. P is equal to m into V. So mass into velocity. So motion under constant acceleration. Please have an attention here, children. So we know that V is equal to U plus AT. Yes, so we have studied this. So mass is given. So you have to multiply with mass in both the directions. M into V is equal to m into U plus m into AT. Okay, so we know that F is equal to m into A. So in case of MA, you can substitute and write it as m into V is equal to m into U plus F into T. Okay, so keep F into T in one side and send m into U through other side. So what happens here? It is plus. So if it changes the side from LHS to RHS or RHS to LHS, so plus becomes minus, minus becomes plus, multiplication becomes division and division becomes multiplication. This you already know, right? So F into T is equal to m into V minus m into U. So mv is given as momentum. Yes, so mu is given as initial momentum and m into v is given as final momentum. So it is mv minus mu, which means the change in momentum. Yes or no? So which means force into time is equal to the change in momentum. Please remember this formula as well. So this problem is based on that formula. So the initial momentum is given, final momentum is 0 because it is stopping, you are stopping the vehicle. So change in momentum is final momentum minus initial momentum. So force is equal to change in momentum by time. So hence you can calculate the force. So the negative sign indicates that the force must be applied in direction opposite to that of initial momentum vector. So what we have studied? We have studied about the second law of motion and about the momentum. Try to answer this question, children. Please pause the video and then write. Thank you, children. We'll discuss about the third law of motion in next class.